Hi everybody, this video today is going to cover section 10.2, which is isosceles and equilateral triangles. And once again, your formatting got a little bit messed up, so this is actually on page 45. The title fell off on page 44, but we're going to start on page 45. So at the top of page 45, can you draw this diagram? You might have to pause the video here. So in this video, we're going to be talking about isosceles and equilateral. And so this is a diagram of an isosceles triangle. And a definition is a triangle with at least two sides that are congruent. So that's why I marked these on the legs, that those are congruent. That little hash mark means that they're congruent. And that's what they're called. The ones that are congruent are called the legs. The one that's not congruent is called the base. So we have two legs and one base. Then we also have the angles have names. This angle at the top, angle C, is the vertex angle, but these angles at the bottom are called the base angles. The base angles theorem says that if two sides of a triangle are congruent, then the base angles are also congruent. So in other words, if we have this side congruent to this side, then we also have this angle congruent to this angle. And so they kind of point down to the other angle like that. That's kind of how I remember it. When these are congruent, then the ones they're pointing to are also congruent. So let's look at a couple of examples. Mark which parts are also congruent based on the picture and write the congruent. Okay, we have this if-then statement. The if is the things that are marked, and then the then is whatever is unmarked. So the if is, look at what's marked, BA and BC. If BA is congruent to BC, that means they're the same size. All right, well, then we look and see what they're pointing to. This one's pointing over here at angle C, and this one's pointing over here to angle A. So if these two sides are congruent, then these two angles are congruent. Let's look at the next one. All right, we have one side marked here and one side marked here, so that's the marked sides. So if BC is congruent to CA, that's this side and this side, then whatever they're pointing to, angle B is congruent to angle A. One more, this one, the triangle looks a little bit on its side, and of course you can twist it any way. It can be on its side or at a weird angle or whatever. That's okay. Even though it's on its side like this is still called the base because it's the one that's not the same. This is still called the vertex because it's the one where the angle is made by the two that are the same. So even though it's on its side, we still use those same words. So again, the if is the ones that are marked. If AB is congruent to AC, that's side AB and side AC, then we look at what they're pointing to, angle B and angle C. The base angles are the ones that are always going to be congruent. If the legs are congruent, then the base angles are congruent. And then we have the base angles converse theorem. And the base angles converse just switches the if with the then. So this time we had if BA is congruent to BC, then the angles are congruent. Well, then now we're going to start with the angles. If the base angles are congruent, then the sides opposite are congruent. So we're going to start with the angles and say, all right, if this angle is congruent to this angle, then this side is congruent to this side. It's just the same exact thing, just kind of going backwards. So mark which parts are also congruent. So if is the marked things. If is angle A and angle B. Those are marked. And if they are congruent, then we look across to where they're pointing to. They're pointing to side AC, and this one's pointing over here to side BC. Same thing here. We're going to look to see what's marked. What's marked? The angle B is marked, and the angle C is marked. That's always our if, is whatever is marked. Then we go to see what it points to. It points to side AC, and this one points to side AB. And those were unmarked to start with, but now that we know it, now we can mark them. All right, now you have some things at the bottom of your page that we're just going to cross off because, like I said, the formatting got messed up. So I'm going to turn the page, ignore those two triangles at the bottom of your page. So mine were up here, I'm going to ignore those. But these I am going to pay attention to. You have all that white space, so just ignore that white space, and let's just take a look at these. we would need to look specifically at what they are talking about and be able to really focus our attention on what they're talking about. And so they say if AB is congruent to EB. Now, with my eyes, those don't look congruent to me. But you know what? They said they were, so I have to go with it. I have to go with what they say. They say that those are congruent. If that is true, then which angles do they point to? So we have to now look and see which angles are we going to talk about. Well, I don't know if you can tell because it's kind of off a little bit, but this one's going to point here to angle A, and this one's going to point over here to angle E. So we have to look at what's marked, go with what they say, and then go to the angles. Now this one's going to be the converse, so we have to do a similar thing, but we'll start looking at the angles. EBC. EBC is this angle right here. EBC, right here. And ECB is over here. ECB. I'm going to erase some of that because it's getting too messy. What I want to really focus my attention on is EBC is here and ECB is here. And so if those two are congruent, then which sides should we talk about? Well, this one points over to this side, this one points over to this side. So that would be EB and EC. And remember, we put a line over it to show that it is a side. Okay, so far we have just been talking about equilateral triangles, or excuse me, isosceles triangles. However, equilateral triangles are also isosceles, it's just a different type. So let's focus on this. Remember, an equilateral triangle has all three sides congruent. So if a triangle is equilateral, then it is also equiangular. Okay, I'm going to come over here and show you what I mean. If this is equilateral, then it is also equiangular. Because it's basically isosceles just with an extra one in it. Okay? Then the converse, again, is similar, just switches the F with the N then. It says if an equiangular triangle, well, it doesn't say if, but it should. An equiangular triangle is also an equilateral. So if we have equal angles, then we also have equal sides. That's the converse, equilateral triangle converse theorem. And finally, each angle of the equilateral triangle is congruent. Remember, the symbol for congruent is this. I had a hard time fitting it in there, but that's the congruent symbol. So if this is an equilateral triangle, then all of these are congruent to each other, and that means, of course, they're all 60 degrees. Okay, using the base angles theorem and the converse of the base angles theorem, find the value of x. All right, what does that mean? What that means is we can see this is equiangular, and if it is equiangular, it is also equilateral. So if this side is 8, then all of the sides are 8. Each side is 8. All right, let's come over here. This time it's not equilateral, but it is isosceles. And notice, here's a symbol and here's a symbol. This one's pointing over here. This one's pointing over here. So if they are congruent on these sides, then the angles are congruent, and then so that is 65 degrees. Now this next one kind of takes it a step farther. And we have the angles that are, the sides that are marked. And so this is 65 because that points over here. This one points over here and says this is 65. This will not be 65. The x is not 65. The two base angles, they are 65, but that one's not. Well, how do we find that one? Well, we've learned that all of the sides of, all the angles of a triangle add up to be 180. So I can make an equation and say 65, plus 65 plus x is equal to 180. And if I add 65 plus 65, I get 130. And now I need to subtract my 130, and I will get 50. So it is 50. Notice that's not the one that's congruent. These two are congruent, not that one. Okay, again, your formatting is a little bit messed up. I need to turn my page, but you are still on the same page. What we're trying to do still is find the missing item. So your X and your blanks got cut off, but let's just take a look at this. If these sides are congruent, excuse me, if these angles are congruent, then these sides are congruent, so X must be 7. Here we have an angle and an angle, points to this side, points to that side, that means X equals 9. Now this is one of the tricky ones. These are pointing down here, that means this is 47. This one we don't know. We have to set up an equation. So we'll do 47 plus 47 plus X is equal to 180. 47 plus 47 is 94. And we're going to subtract that 94. And if I take my calculator and take 180 minus 94, I get 86 degrees. Okay, so X is 86 degrees. All right, now you are on the next page, and my page is here. Let's just finish up these last two examples, and then we're done for the day. These two are congruent, which means that if this is X, then this one is also X. What do we do with the 38? Well, you have to set up an equation. You have to say X plus 38 is equal to 180. And so now I'm going to subtract that 38, and when I add X plus X, do you remember X plus X is 2X? Because it's like a 1X plus a 1X is 2X. Now I'm subtracting my 38, so over here that's going to give me 142. I need to divide by 2, and I get X equals 71. So in this case, X is 71 degrees. Last one should be easy. Can you see what it is? Because these are congruent. They're pointing that way. So X is 11. All right, we will have some more practice in class on how to work with the isosceles and equilateral triangles.